today's topic is going to be DNA and SD access in routing and switching, even though other platforms like wireless supported there as well. So since I'm routing and switching engineer, I think it would be fair enough to comment from that side. So an agenda for today is, first of all, we will talk about the DNA center overview, and then I will give you a brief demo, what it is about, what are the benefits, how can you use it. Then we will talk about SDA overview, and we will reserve for some time for questions and answers. So yeah, that's the plan for today. And yeah, if you will have any questions or let's say queries, please let me know. So yeah, we can discuss them during Q&A session. So yes, so first of all, maybe like a question to students now. Basically, what they are like. Okay, now it may be a bit rhetorical question, but think about, what do you think about Cisco? So what is that? It could be routing and switching, so maybe some catalysts, or it could be wireless technology, or it is servers, or etc. And now Cisco is trying also to be a solution company, so to combine all the portfolios under one solution in order to manage, observe, monitor, so to say, let's say, give better visibility of different aspects of the network. So not only provide the hardcore networking, but actually some, let's say, managing and monitoring of those solutions. And that is why we have this DNA center, so which is, let's say, single solution to address that. And before that, you might also like another rhetorical question. So like how this information, how knowledge of this DNA center or SDA would be useful for you. So first of all, we really hope that you're interested at Cisco. So this is actually one of the trendiest topic in our company. So this, in case today's session will inspire you, especially DNA part, yeah, we are more than happy to see you to apply at Cisco. And secondly, the industry is changing. So the traditional network that it used to be, let's say, large scale networks, and there is one application for pushing configuration, another one is for monitoring. And let's say there are, let's say, a lot of, let's say, kind of issues or drawbacks of existing ways how the networking used to be done. A lot of legacy devices, yeah, sometimes misinformation, or even not when you have a really large scale network, sometimes it's hard to track all the changes, what is going on. And that is why, yeah, we have this DNA center, which is both ways used by Cisco and also by customers. So even though if at one moment you decide, oh no, I won't go to Cisco, I will work, for example, HCPC or another like large scale customer. Over some time, they are already either like moved to DNA center or about to do this. So it's, let's say, a new trend. So yeah, that is why it might be useful for you. Okay. So by the way, this is example of that slide because there are a lot of information, but it's on the other hand, it also summarizes, let's say, nicely all the main points about DNA center, what it is about, and what are the expectations. So yeah, like these traditional box-to-box deployments, they are not very scalable. They are providing, let's say, monitoring issues, troubleshooting issues, let's say. So yeah, imagine that you're a large company and you're working across Europe or maybe worldwide. The number of devices are thousands, like thousands. And to track them all, it's quite hard. Of course, there are like, let's say, some solutions like from Cisco, Prime, or IPAM for pushing configuration. But what about monitoring? Okay, there is another network monitoring tool. What about, for example, health check and overview of devices? Another tool. So as a result, yeah, like let's say, the whole idea of DNA Center is to provide centralized management, design, provision, and also, let's say, design and provision of devices. So basically overview of the network. So getting your hand on the pulse, what is going on. Automation. Automation in a sense, how do you add new devices? So in terms of scalability, or how do you, for example, how do you deploy new features across devices? Because right now, for lots of companies, the big, let's say, the big headache is this legacy network. And if they would like to implement another application or another, let's say, like trendy feature, it will require a lot of, let's say, work. While with centralized, you can actually push configuration on multiple devices. And it could be, for example, also like automation with granting the access or branch deployment with SD-WAN. Assurance. So basically, it's for contextual data, information about business and operational insights. So it could be traffic flow, application usability, or maybe even like usage of particular, like, let's say, what are the experience of usage particular application. Security. So by having centralized overview, we also can, let's say, identify gray areas in the security. So maybe there are some issues with segmentations or security policies across the network. So basically proactively identify and avoid potential issues. Okay, virtualization. So basically deploy any services in a minute in any platform, on a branch or in a public cloud. So this for today, we won't use that much. We won't talk that much. Open platform, so basically ability to integrate and ability to innovate with different, let's say, vendors or different applications. So it's integration and policy integration. So basically how you align your policies across the campus, branch, data center. So basically different policy for different parts of the network. So again, centralized management, automation, assurance, security. That I would highlight the most, and policy integration, and of course virtualization and open platforms. Okay, so Cisco DNA, very broad and let's say broad overview of what is this. Okay, there are several DNA solutions which I will now cover on. A bit brief. So the first one is Cisco DNA. So this is actually a DNA center. So basically it's a portal that provides those, let's say, features that I previously said. So policy management, automation, analytics, security overview. And later on, we will have a demo on DNA center. The next one is SDA access. And this is also we will cover during today's session in the second part, where we basically will talk about how we're providing the, let's say, first of all, network segmentation and access to different applications between users. Last but not least is SD-WAN, how you actually can deploy and transform your remote sites. Like the focus here is obviously on the WAN context. Like as a part of today's session, we will leave it out, but yeah, hopefully we will have another session where we can cover it more in detail. So before we will go into the demo, let me check, do you have any questions? Let me check, how can I check the messages? Chat window. Okay. Yes, you can type your questions in the chat window if you have them. Looks like we don't have them now. Let me remove this one. Okay. All right. In that case, demo. So basically for this demo, unfortunately, I'm not able to go to the real DNA center because there is containing my customers' information, and Cisco is very, very strict with what information is flowing. but I will try to, let's say, using the power of screenshot to explain how it's basically used, because yeah, previously we said about lots of let's say advantages, but how they look like in reality. So this is what I would like to achieve with the next part, with the next step. So basically, this is how DNA Center looks like. So it's a single portal which provides information about the device health check or overall their, like, let's say, percentage, critical issues in the last 24 hours. So P1 is like something business impacting. P2 is also critical, but yeah, like less critical. Then like number of sites are displayed here, network devices, and application policies. So basically, this is your starting screen of all the information that is there. So like provides you certain visibility. So if I will come back to like, okay, so the next slide. Guys, first of all, since yeah, we are quite strict with data flow, some of the customer sensitive information are hidden behind this. So it's CIA style. So, but I hope it will still reflect the context of what we're trying to say. Okay, so the first advantage of DNA Center is the way how you can actually see, observe your network. So basically provide you extra visibility of what's going on. And the first step, as me network engineering is doing, is actually creating the site-specific, let's say site-specific overview. So specific locations, for example, like Denmark, London, or Krakow, or Moscow. So different sites of your customer. And yeah, try to imagine now yourself as a customer. So all these locations are the branches. So for example, it could be, I don't know, a shop or a restaurant or university branches. So for example, each site 1, site 2, site 3, are actually representing the branch across the globe. And this information is configured, let's say, by Cisco engineers. So it's not doing, let's say, it's not done by magic when you're plugging the box, it automatically pops out in there. Now, unfortunately, this is like the homework which needs to be manually done. So basically, first identify main sites, main branches. Then, for example, okay, site number 1, for example, Moscow. Yes, there are, like, for example, one building. For example, university, which contains of multiple floors. And for each floor, basically each floor, it could represent that, for example, there is located one access point or WLC, or for example, catalyst switches. So why it's important to do, let's say, such detailed overview? Well, because later on, when we will push some configuration from DNA Center, we would be able to understand, okay, where exactly we would like to push that configuration. Do we like to push them across the globe everywhere, or it's only site-specific one? Okay. So the next step is basically configuring the basic network settings, such as AAA server, client endpoints, DHCP server, DNS, SNMP. So basically basic network information about your customer. Okay. I heard some strange voice in the noise. I hope no questions. By the way, if you have concerns, those are public IPs, so yeah, they shouldn't do any violation to my customer. Okay, the next one is actually C-layer credentials. So why we are doing it? So basically DNA would be able to access those devices, first of all, for the configuration purposes, second, for the monitoring, third, if we would like to receive some output. So here, for example, the name, username, password, and yeah, enable password if it's required. So again, site-specific information, network-specific information, global C-layer credentials to access devices. So the next step is image repository. So here you actually select 4 specific platforms. For example, Catalyst 3850, Catalyst 9300. Oh, sorry, we went back. We don't want to do that. Okay, so basically those are the platforms which my customers are having. And here, and basically Cisco DNA is able to access a web page called software.cisco.com, software download. So basically from that website, you can actually download the software images for your router, switch, UCS, and etc. So basically, yes, once we're saying, for example, okay, 9300 is going, for example, with this release, it means that, yeah, if we would like, for example, to do the software upgrade, it will be populating straight from DNAC SDA. Couple of things I would like to clarify. For one platform, you can actually provide multiple different software versions. Depends on the use cases. So for example, for your customer used to have one software version, then another, then another. And in order, for example, not to mix them up, you select the golden image, the one that is currently, let's say, recommended. So they would be able, let's say, for example, if they're running non-compliant version, it will be highlighted, okay, dear Mr. or Mrs. Customer, please double check your current software version because it's not compliant. Okay, and by the way, one minor thing. So you might ask, okay, for example, we have 9300 switches. In some places, it's used as an access switch, but in some, for example, they could be used as a core. So in that case, you will create another such imported, like let's say, such profile. And if you have different software versions, you will select different software version. The only, let's say, difference will be device role. So it could be core, all, or for example, access distributed. So yeah. So the next one is actually more interesting in my opinion, is actually the way how we, sorry, my dog in the background is doing some strange noises. So please, I hope it's not very disturbing. So yes, now this is the part where actually we configuring the configuration template. So how we are doing that? So we first of all creating a profile, basically profile for specific, let's say, usage. For example, test network, lab network, or maybe production, the one that we previously showed in Moscow, or maybe even a global one, so for all of devices. We're selecting type of devices and which sites, let's say, they're correlating. So basically, yeah, here is how you actually create the profile. So you select type of device, then device tag, if it's access or, for example, distribution, and then a template. And this is actually the template. So here you actually specify. So unfortunately, there are a lot of information now is hidden because here is actually a customer's configuration file, with not actually configuration file, but changes that we would like to implement to the configuration file. So unfortunately, I had to hide that information. So, and basically, yes, in that template for example, site, for example, test one, there are following changes that we would like to implement. For example, in VLANs and for example, in the port configuration. So simple change. Here we specify, for example, text, which actually, let's say, part of the networks, so access, and then type of devices. So Catalyst 9300, type of the software, iOS XE. And for example, if you think, for example, okay, maybe there was a mistake in the config, or you would like to roll back, no problem. All those, let's say, different config versions, they actually saved in repositories. So in case you will need to roll back, you can select them here. One minor thing I would like to say. So even though if you have something here, first of all, you will afterwards will need to save it and then commit. So basically deploy to the device. and a device or number of devices which are corresponding to this group. So and there you can select two options, either to do it now straight away or force under specific times. So usually in production, people are network changes are done during maintenance windows. So there we can actually specify, for example, the time when we would like to deploy config, and also, let's say, including the local time. So you shouldn't worry about that. So again, this could be a template for specific device or devices in one location, or we can do it globally, for example, global configuration change. So imagine instead of going one by one device, we can push it centralized. And we have, let's say, multiple options. How can we actually can download oh, sorry, directly to devices, right? Yes. So basically, we have a question. Can we download software upgrades directly to devices? So basically, first of all, let me come back to that slide with software versions. So basically, yes, basically software version will be downloaded directly to device, but it won't be committed. So for example, if you would like to perform the software upgrade, in that case, you will need to specify the exact day and time when you would like to do it. So yeah, to upload from DNA center to devices, you can do it straight away, but the actual commitment, let's say the software upgrade, during specific times. I hope I answered that question. Okay. Let's go back. So again, we covered the network overview, how we can more effectively see observe the network. Then how can we push configurations to devices? Now, how can we actually discover and end devices? So the discovery is actually based on the IP address. So basically, yes, this is going to be example of the brown field. So basically, the box is already in the network, but it's not connected to DNA center. So how we're doing? So we're specifying the discovery name. Then we are selecting, for example, using CDP, LLDP protocols to discover the device, or using IP address actually range, where you specify, let's say, okay, the pool of devices that you would like to add. Next step is actually the credentials. So as you can see in this example, they are already pre-populated. So CLA, SNMP for read and write. This is actually what we previously already done in this step. So if you remember, so when we were configuring AAA server, DHCP, CLI credentials, so this is where like good preparation pays off basically. So it means once you filled out that information, adding new devices to DNA center should not be a problem anymore. So basically, yeah, it's all pre-populated. And this is how the device discovery is done. So in our case, the IP range was only of one device. So the protocol was used SSH. And here, for example, we have, let's say, check mark. So first of all, yes, device was discovered. So is it pingable? Can SNP read and write, CLI, netconfig, and then like success or failure. So this is how we can actually add new, let's say, add new devices to the DNA center. So basically specifying their IPs. Okay, the next step. Okay, it looks like there is customer name, so I will come back. So basically, so this is a device deployment. But imagine for a moment, you have a network issue. So something is not right with your network. And you done the basic troubleshooting, and then you decide to open Cisco tag case. So basically a case to Cisco. So Cisco engineer on the other side will connect to your WebEx session, and you will together start to troubleshoot the issue. So this is actually the like time where DNA Center allows you to, let's say, shorten the amount of time to get the information, because Cisco engineer will require, let's say, for example, show running information, show tag. And basically from DNAC Center, you can export some of your configuration files. So and basically the configs are already predefined. So there are like list of commands which you can actually extract. So not something that what you can type, but already predefined. And when you will be sharing that data with Cisco, for example, and if you're containing some sensitive information, for example, passwords or like some security implications, it's going to be actually deselected. So it's going to be XXX. So you can straight away provide that output. So again, like when basically like network is burning and the time is valuable thing, from DNA Center, you actually would be able to populate config file, send it to Cisco, and already start to do the troubleshooting. So yeah, that's basically about, let's say, key takeaways about DNA Center. Devices location, traffic flow. We today only covered device locations, but of course, yeah, it could be also application usage or other areas. Then device configuration and management. So yeah, if you have some configuration to push, you can do it centralized. Yeah, like any let's say devices you would like to do so. So simply your time. And device discovery, adding them, yeah, simple as that. So yeah, that's the key takeaways solution called Cisco DNA Center. Okay, so do you have any questions before we will move to the topic of SDA? And I will give some time maybe to type in the chat window. So please, do so. Okay. As you can see, it was also an opportunity for me to sip a glass of water. Okay, I hope it was a bit self-explanatory. So basically, in that case, how much time do we have? Oh, that was a bit fast. Okay, in that case, yeah, we will now go to the software-defined access topic, SDA. So something that you can have on top of Cisco DNA. So basically, let's move next. So basically, we have here traditional tier 3 network, which is, yeah, as some of you may say, actually, okay, like, but you actually can combine current distribution, like, yeah, it's also possible. But yeah, this is the most traditional, let's say, based on the book network. And yeah, like basically here we have VPC between, for example, 6500s. Then we have configured port channel, STPs, basically, and also link redundancy. So lots of, let's say, features enabled, which in case something goes wrong, is getting harder to manage. And you may say, okay, in that case, why not to skip layer 2 and go to layer 3 only? So only to have IP routing. So basically, this way we will skip lots of issues. It will be easier to troubleshoot and yeah, easier to manage. So it will save our time and nerves. The only and that would be actually ideal scenario. The only problem is the user segmentation, because in that case, yes, basically we will need to specify the access lists. So imagine users are moving between floors, and yeah, that user won't be able to join to start to work there, continue to do their job on the other floor, which is quite frustrating because yeah, basically they're not allowed in, they're not in the ACL for that specific part of the network. So what we have here, basically a trade-offs. On the other hand, we would like to have stable network, which are easy to manage, easy to, let's say, configure, and let's say easy to monitor. On the other hand, we also need to think about user flexibility. So basically, who are our end users, and how comfortable and how useful for them they can actually use, let's say, the applications that they are using. So we decided to combine best of those two worlds with Cisco SDA. So, and SDA, you might think that it's, if you're familiar with the concept of ACI, in some sense, yes, they're actually quite familiar. While SDA is more focused towards the campus networks, towards LAN and switching, towards, enterprise, while ACI, it's data center. So basically, I would say like this, if there is one thing I would like you to take over from what is actually SDA, the end goal of this solution is to provide single platform to deploy the devices, monitor, and this monitoring is not only the network devices that we are having, but again, applications, traffic flow, and also security. So to whom we're giving our privileges, who is able which information to access. And yeah, here is basically policy, automation, analytics, what we covered here. Okay, so before SD access and after SD access. So what is one of the benefits is actually that you basically implement one single policy both for wired and wireless networks. So you don't need, let's say, create it for only for one specific wired or wireless. So as a result, it eliminates the issues of roaming between all three domains. So basically, yeah, users will roam freely, between, for example, different floors. So if you go down, you will roam to that network, and you still will have, let's say, the access to your applications. And yeah, basically, yeah, that's the main takeaway. So I also hope I won't be I'm trying to keep the balance, okay, not maybe too high level, but also not going too much deep. So let me know if I'm still keeping that balance. Good. Okay, so fabric. So basically, if we will think about traditional policy model, which is used in the network, is access list. There we specify, for example, okay, IP address, type of traffic, UDP, TCP, and then of course we manually need, for example, okay, allow or deny. And it's a lot of manual work requires, and it's not flexible. So as a result, basically, yes, as a result, Cisco went with the solution called Fabric. And the key takeaways about the Fabric. So again, it's containing of three components. So it's a control plane. So basically the management based on Lisps. Lisps are mostly used for to identify, for example, routing locations, so where to route, and also users, so from whom. Data plane is based on the VXLAN, we will cover a bit later, and policy plane is based on CTS. So in order not to overwhelm with too much information, it's a bit left for another time. So yeah, I hope we'll have opportunity to deep dive there. So basically SD access, VXLAN. So fabric nodes are using VXLAN, basically a data plane which supports layer 2 and layer 3. And VXLAN contains of the header, VNID, basically a unique identifier which is assigned to the user, specific users. And we can have those IDs up to 16 million. So far, I don't know any organization which could contain that amount of people. So, so for now, it's more than enough. Another thing is actually called group policy ID. So basically, a tag for specific, let's say, department. So, for example, if we will take, for example, your campus. So there is, for example, one goes for 2 professors. Second, for example, to the network administrator. Third one for students. Fourth one goes, for example, to visitors. So next time I will visit your campus, I will be assigned like to the 4th group user. So yeah, that's an idea. And basically, group-based policy is ingress and egress enforcement. So let me. So basically, the whole, let's say, enforcement is done only based on the destination where you would like to forward the traffic. Why we're doing it? Well, first of all, to narrow down and to save some memory of devices. So by only having the, let's say, the target where we're aiming at, this is where we, for example, this is actually like the, yeah, sorry, lost the thought. So basically, yes, where we destined the traffic about. So in the encapsulation, we are having following information. So VNID, then group ID, it's encapsulated, goes through the network without unpacking, and only at the end, at the edge node, it will decapsulate and move the traffic towards the destination. Okay, an important topic, an important part of the SD access is, of course, the fabric segmentations. And there are 2 ways of doing that, micro and macro segmentation. So micro segmentation is when we segment users within one virtual network based on SGT. Let me check. Yeah, SGT we will have in the next slide. So basically, yes, all the communication done within one virtual network, and communicate is based on role permission. So as I mentioned previously, basically, yeah, like if we specify our destination, this is where our traffic is targeted. Oh, and yeah, and macro segmentation. This is actually based on the virtual network level. So first of all, why we actually would need something like, let's say, creating different virtual networks. So for example, if you will be working for government or military or hospitals where actually data protection and access is very strict. So basically within let's say one virtual network is not able to access another virtual network. So all the communication is done only between them. So yeah, and yeah, this is based on VRF, and we will cover a bit later. So now we will focus on the microsegmentation SGT. So what is it is? So SGT is actually basically identification of the user, and it's dynamically assigned to the users which are coming to the network fabric. So basically nodes adding SGT in the fabric encapsulation when they communicate between users and devices. And edge and border nodes enforce ACL policy, SG ACL policies. So basically to protect unwanted communication. So yeah, basically that's all. Basically one tag which allow you, for example, permit or deny communication. And so for the topic of SDA, actually don't have, let's say, demo, but for example, yes, if in case of ACL, what will require you to make an access, for example, to specific, let's say, application or part of the network? You go on the device in the ACL, you, for example, okay, provide the IP address of that user, type of the traffic, allow, deny. It takes time. It's a bit, let's say, frustrating. While here in the portal, you would be able to specify, okay, users with set following tags are able to access those applications. So in the matter of clicks. Okay, I'm coming back now to the this again slide. So now we will talk about the macro segmentation, in particular virtual networks. So virtual networks and yeah, how it's basically is working. So how the virtual networks look like. So first of all, of course, it's underlay. Well, the actual devices which provide the connectivity. The next one is called infra VM, and it's only used for the wireless communication. So wireless users and communication is kind of in priority since they have, let's say, own VM. Then we have the default VM, where actually users can act, where you actually provide the access to the users. So you can have one single VM, as we specified in the micro-segmentation, or we can have user-defined VMs, basically based on the let's say, different VMs, and like to eliminate access from one to another. And virtual networks. Virtual networks mean, oh, my headphones are dying. So basically, virtual networks are maintaining a separate routing and switching table for each instance. So provides macro segmentation. Control plane users uses instance ID, the one VN ID, to maintain separate VRFs, which we covered previously. And fabric nodes adding VN IDs to the fabric during the encapsulation step. So basically, yeah, that's an idea. And I would like to give you a sneak peek how basically VRF okay, VRF, for example, campus and VRF guests. And there you specify, okay, so VLANs, and I would like to point out one attention. So for example, if you can see that in those two, the MAC address is the same. So the reason for that is to have, let's say, single last resort. So basically, users would be able to roam between, let's say, between networks. So that's an idea. So again, the whole concept of SDA is actually providing a granting access to different users. I would say painless. So for example, if you're adding new applications or adding new users, to configure and allow them access should be in a click of banner. So basically, okay, that user is allowed to access that type of data, that user allows access that type of data. And of course, those segmentation, segregation is just a details. How can we actually do that? In joining Cisco or continuing your path about the, let's say, SDA, so it's not only about routing and switching, it's of course wireless and extenders. Have an opportunity to be part of that. And I would say like this, in case you're interested, so there are like lots of, let's say, devices which are supported, but I would give my advice from this perspective. if you will be responsible, for example, for network design, or for example, SDA solution architecture, think about the device capacity, memory, CPU utilization. So basically, it would be able to handle those kind of processing. So ability to, for example, encapsulate the data, enough the memory and bandwidth, and also perform in the network segregation. List extenders, they're like working as dummy boxes, basically to provide switch capacity. So they are more operating on the data flows. So while those devices more on the control plane. Okay, I thought I had a bit more data information to share, but yeah.